All right, so in this video, we are going to do a review of chapter 1.1, which is basically functions. A lot of it is a review of grade 11 math, and we're going to cover two main concepts in this video. The first concept is domain, and the second concept is domain and range, I guess I should say. And the second concept is basically whether a relation is a function or not. So is it a function? And for this, when we have graphs, we're going to do something called the vertical line test. So domain and range is something you covered in grade 11, so you should know a bit about this, but I'm going to explain it a bit more as well over here, just in case you didn't understand it then. Domain simply talks about your x values, and a range simply talks about your y values. We can have two types of questions. We can have individual points, or we can have joint lines. Okay, so just keep that in mind. There's two types of questions for this. So domain is your x value. So let's say, for example, you have three possibilities of your domain. You can have something that goes, for example, I'm only going to do this in one dimension right now. So we're not going to do range, but the same rules apply for range. You can have a condition like this where you have the graph going to the left forever and then the graph going to the right forever. So this just means that x can take any value. X can be -5, x can be +10, x can be 1 million, x can be -1 billion, x can be 0.00005. X can be any value if you have a function that spans like this, which means that our domain is just all real numbers. You can have a function that looks something like this, where maybe this value is -1. So in this case, x cannot be -2, x cannot be -3, but x can be any value greater than -1. So here our domain is all real numbers such that is greater than or equal to -1. Similarly, you can have something going in the opposite direction. So this is a single condition. This is no condition, single condition. This is also a single condition. Let's say this is 5. Over here, x cannot be 6, 7, 8, or any number larger. X has to be smaller than 5 or equal to 5. So here my domain is all real numbers, and it's less than or equal to 5. And then the last possibility is you can have a double condition. For example, this could be -3, this could be +2. So over here, basically, x can only be any value between a -3 and +2 inclusive. So when you have a double condition, you write it like this: -3 less than equal to x less than equal to 2, which just means x is between -3 and +2. The XER just means that you can take any whole number or decimal value in between. It just means x is an element of all real numbers. Okay, the same thing applies to range and the y values, but I'm not going to do the same examples again. It's just up and down. We're going to get into some actual questions. So the first question here is going to start with a graph that's basically trigonometric, and it just goes like this forever in both directions. And your minimum is -4, your maximum is positive or -2. So in this case, if I think of my domain and range, let's start with the domain first. This graph is going to go to the left forever. It's going to go to the right forever. So it's this condition here. So my domain is all real numbers. And let me think of my range. My smallest y value is -4, and my largest y value is -2. So basically, y is between -4 and -2. So my range is just -4 less than equal to y less than equal to -2. Okay, let's take a look at the next question. The next question is a graph that looks, oops, that should be flat, like this. And this point over here is -1, -1. This height over here is +1. And then this point over here is 7, and -3. So in this question, first of all, there are no arrows. So these graphs end at this points over here. Let's start with our domain. We know this is a connected line, so we're going to start with all real numbers. My lowest x value is -1. My highest x value is 7. So x is basically between -1 and 7. My lowest y value is -3. My highest y value is +1. So y is between -3 and y +1. Okay, so now you're getting the idea of doing it from graphs. But let's say, for example, you had some points. So let's say you had a list of points like this: 1, 4, 1, 9, 2, 7, 3, -5, and 4, 11. So when you have individual points, you're not going to put x or y as an element of all real numbers because it doesn't take any decimal values. So my domain in this question is just x equals 1. I don't have to repeat values. That's 1 again, 2, 3, and 4. So my x values are just 1, 2, 3, and 4. Sometimes the teachers don't even put the x equals. I'll ignore that as well. It really depends on which class you're in. And my range is just my y values. So my range, I'll write D and R over here just to make it clear. My range, my lowest y value is -5. Then the next lowest one is +4, 7, 9, and then 11. So that is my domain and range for individual points. Whereas if I have connected lines, that's how I do it. And before I go to the next question, I'm going to talk about the second concept here, which is whether it's a function or not. Okay, a relation is a function if every x value has only one y value. Okay, if an x value has two y values, it's no longer a function. And I'll explain the vertical line test from the graph as well. So if I look over here, if I have a graph, I'm going to do a vertical line test. Is there anywhere on this function where I can draw a vertical line that will pass through 2 points? No, that's not true because there's no place like that, which means that this equation is a function. But let's say, I'll show you another example really quick. Let's say I had a graph that looked like this. Well, if I draw a vertical line over here or anywhere, I'm passing through 2 points, which means it's not a function because it fails the vertical line test. And simply one x value cannot have two y values for it to be a function. Okay, so let's come back over here to this one over here. If we do a vertical line test over here, this is a function. There's no place anywhere I can draw a vertical line that will cross 2 points. And over here, well, if we look, my x value of 1 has 2 different y values. If you plotted this on a graph, you would notice that this would fail the vertical line test because x value of 1 has 2 y values, which means that this is not a function. Okay, so now you have an idea of what we're going to do in this entire lesson. This is it in terms of concepts. I'm just going to do a ton of examples and show you all the different ways you can have examples. So next question, we have an equation, y equals to 3x minus 5. This is just a linear equation. Now the domain and range for any linear equation that has a slope of not 0 is always all real numbers. Okay, and this is always going to be a function as well, as long as you have a slope that's non-zero. Now, I'll plot this really quick to show you why. This is -5. It's a linear function with a slope of +3. As you can tell, this is going to pass the vertical line test, and domain and range are both all real numbers. Like I said, that applies to all linear functions. Next example, we have y equals negative 5x squared. This is just a negative quadratic function. So again, pretty simple. You want to sketch it out. We know that the vertex is 0, 0, and it opens down because it's negative. There's no transformations left, right. That's why I know my vertex. You should know your sketching pretty well. My domain is all real numbers, and my range is all real numbers. And as you can see, my lowest value is negative infinity, but my highest value is 0, which means that my range is y is less than or equal to 0. Hopefully you're starting to get the hang of it, but I'm going to show you a lot more questions. And also this is a function as well. All quadratic equations, again, are functions just like linear equations. Take a look at the next example here. Y equals to negative 2x plus 1 to the power 2 minus 3. So this is a quadratic function in vertex form. You should be able to sketch this instantly. I know my vertex is negative 1, negative 3. So negative 1, negative 3, and it's a negative function, negative a value. So it opens down. Negative 1, negative 3. So my domain is all real numbers. That's true for all quadratic functions. My range, again, this one's opening down. So it's less than or equal to negative 3, my y value right there. And this is a function. All right, next question is a reciprocal function, 1 over x plus 3. So we know that from grade 11, you should probably know this, that a reciprocal function is, a reciprocal function has a vertical asymptote, which is the solution to the denominator. So x equals negative 3, and a horizontal asymptote at the c value, which is 0. So a horizontal asymptote is 0. There's no reflections, no negatives out there. So when the original two quadrants, which are like this. So my domain over here is all real numbers, and x cannot equal to negative 3 because I basically take all values except the vertical asymptote. Similarly, my range is all real numbers, and y cannot equal to 0, my horizontal asymptote. And this is a function. Again, all reciprocal functions are functions. Next one is y equals 2 to the power of negative x. This is an exponential function. The value here is greater than 1, so we know it's exponential growth, but it has a transformation over here, which is a reflection in the y-axis. So we know that exponential functions have an asymptote at y equals to 0. I mean, it's basically the c value, but there's no c value here. So in this case, it's 0. And it normally goes like this. But since we have a reflection in the y-axis, it's going to look like exponential decay. This point here is 1, but that's not important for domain and range. So my domain of this function is all real numbers because I go to the left towards infinity and towards the right. My range, however, my lowest y value, it doesn't even hit 0, but this comes really, really close to 0. My highest is infinity. So it's y is an element of all real numbers such that y is greater than 0. There's no equals because it never actually hits 0. It just gets really, really, really close, like 0.0000, infinite zeros, and then you have a 1, gets super close over there. And exponential functions are also functions. Right, next one is a trig equation, y equals cos x plus 1. So this is just a regular cos function that's shifted up by 1 unit. Let's draw it like this. So cos graph normally starts at the max, which is 1. But since it's shifted up by 1, it's going to start at 2. Usually goes to the min, which is negative 1, but shifted up by 1, so it's going to go to 0. And it's going to repeat forever in both directions. So again, if I go to the left, it's in negative infinity. Towards the right, it's positive infinity. So my domain is just all real numbers. My range, my minimum y value is 0. My maximum is 2. So y has to be between 0 and 2. And again, this is a function because it passes the vertical line test, and all trig functions, well, sine and cos at least, are functions. So don't have to worry about that. Right, let's go to the next question. Let me just grab another sheet. Next question is x squared plus y squared equals to 9. As you can see, I'm covering all the different concepts possible. I won't repeat any of the same types of questions if I can avoid it. This is the equation of a circle that's centered at 0, 0. And the radius is the square root of this number, which is 3. So my domain over here, my lowest x value is -3. My highest is +3. So x is between -3 and +3. Range is the exact same because y is also between -3 and +3. And this equation is not a function, because if I do the vertical line test, let's say I do it over here, it's going to cross 2 points, which means it's not a function. All right, next one is a sine graph. We have y equals to 2 sine x. So this is a sine graph with a vertical stretch by a factor of 2. So that's going to look like a regular sine graph. It starts on your axis, goes to your max, min, and then repeats forever in both directions. The max is usually 1, but since it's stretched by 2, it's 2. The min is -2. So my domain over here is all real numbers. That's true for all sine and cosine functions, like I mentioned earlier. And my range is between -2 and +2. This is going to be a function. All sine and cos functions are functions. Okay, you definitely should have a much better idea of it right now, but let's do just a few more questions, a few more important ones. The next question is a set of points and they're represented in circles. So this is my x values right here, 1, 3, 5, 7. And this is my y values over here, which is 2, 4, and 6. And then to create points, they have arrows. So my first point is 1, 2. My second point is 3, 4. My third point is 5, 4. And my fourth point is 7, 6. So let's start with the domain. When I have individual points, my domain is just the x values, which is 1, 3, 5, and 7. Do not write an x element of all real numbers. My range is just my y values of 2, 4, 6. And this function is going to be a function because there's no x value that has 2 y values. You don't see 2 arrows going from any individual x value over here. So this is a function. The next one, again, it's the same type of question, circular one, just slightly different in terms of the points. So we have 1, 10, 100, and here we have 0, 1, 2, 3, and then the first arrow goes there. So my first point is 1, 0. Then my second one is here, which is 1, 1, then 10, 2, and 100, 3. So my domain here is just the x values, which is 1, 10, and 100. My range is just the y values, which is 0, 1, 2, 3. And then this one is actually not a function because you see the x value of 1 has 2 different y values. Okay, last thing we are going to do is I'm going to do some slightly more complicated questions now. The lesson is almost over, I'd say. Maybe 3 or 4 more questions, maybe even less. But the next one I'm going to do is basically a sideways parabola. Just have a parabola that looks like that, and this point over here is 1, 1. So this one, my domain is just x is an element of all real numbers. And as you can see, the lowest x value is +1. x has to be greater than or equal to 1. My range, this graph goes down infinitely, it goes up infinitely, so it's just an element of all real numbers. And then this is not a function because it doesn't pass the vertical line test. Okay, that pretty much should cover it. I know there are some harder questions. I'll mention this really quick. Sometimes you can have a question which is like this: x squared equals 2y plus 1. This is just a quadratic function, but it's not it's not in the right order. So you want to rearrange things around. I'm going to move the -1 to that side. So x squared minus 1 equals 2y, and then I'm going to divide everything by 2. So I have x squared over 2 minus 1 over 2 equals to y. This is just a quadratic function that has a horizontal compression by, a vertical compression by 1 over 2, and it's also shifted 1 over 2 units down. It's a bit hard to tell, but basically it's a positive quadratic function with the vertex at -12. So it looks like that. So our domain is all real numbers for any quadratic function. Our range is just y is an element of all real numbers and y is greater than or equal to -12. You can also get something like this where you have x equals to y squared. Now, this is a bit of a tougher one, but again, something you definitely want to know in grade 12 and should be easy because you will get questions like this, but much harder. So x equals to y squared, well, this I can tell you for sure, anytime you have y squared in a question, it's going to not be a function for sure. I'll actually explain why. When we want to isolate y, we need to square root both sides, which means I'll get plus or minus x equals to y. And this plus or minus over here is going to make sure that you have two different values for every individual x value, which means it's not going to be a function. You think about the graph here, it's a sideways parabola that looks like this. And my domain is all real numbers that's greater than or equal to 0. My range is all real numbers, and there's no condition because it goes up and down infinitely, and it's not a function because it fails the vertical line test. So I've covered the basics of this chapter. If you enjoyed this video, please like and subscribe, and I will be posting more videos like this pretty much almost every single day going forwards.